So on this modification, these two nuts you can't get a socket on to torque, so I just use a wrench and good and snug. So in the last video we disassembled the transmission and inspected it, and actually the transmission looks really good. Some of the dog rings are where the wear generally is. So we now have new dog rings. I don't know how easy it is to see the difference, but this is our new dog ring. This is our old dog ring. So the edges wear from engaging the gears. So we are replacing the dog rings. One of the other items that I like to do in these transmissions, so you can see how beautiful the CNC work is on these bearing plates. All dog ring transmissions tend to shed some metal material. Obviously that is where, you know, all of this metal that wears off of these dog rings has to go somewhere. In many dog ring transmission applications there are magnets inside. There are no magnets in this transmission. So what I like to do is I go in here and I install a fairly large magnet in the bearing plate. This is the plate that sits just on the back side of the main case. So this magnet will catch all of the fuzz, and that's mainly what it's going to be. Now the reason that we want to do that is so all of this steel material does not get into our bearings, whether it's these small needle bearings or the larger bearings in the front and rear case. So we will capture a lot of the material, which really will just mainly be fuzz, with this magnet. So that's one of the things that I like to do in these transmissions. So as I mentioned before, these have O-rings. However, for an O-ring there's always a split, and the split you would always put at the top of the case. Obviously less chance to leak when you're sitting static if the split is at the top. So what I like to do is take just a teeny tiny bit of clear silicone and just put a tiny drop right at the split, which will prevent that from leaking. So let's go ahead and assemble this transmission. On this modification, these two nuts you can't get a socket on to torque, so I just use a wrench and good and snug. So there our bell housing is assembled onto the main case. So now we can start stacking everything up. there's our main gear stack. If you've never done it before, the best thing to do when you're disassembling is to lay it out in order so that you can't be confused, because it's very easily to be confused. Other than that, you just need to make sure that everything kind of goes back the way it went. These are actually a little bit easier than the older PBSs because the spacers in between the gears on the spline side are all the same. The shimming on the drive side is slightly different for two of the gears. First and second. First gear is a little bit thicker, so they provide you with a longer bearing race, which confused me for just a second if you were watching. But got that figured out, no problem. So now we will continue to stack and go from there. Okay, moving forward to our locks. If you were watching the disassembly video, you remember that I ended up breaking one of these because I did not pull it out before I untorqued this nut. It's a common mistake to make, and I believe I also mentioned that these locks were fairly inexpensive. I was wrong about that. It's been a while since I've had to buy one. It was about close to $100. So since I broke it myself, I certainly can't be charging the customer. So that's a bit of a money loser for me on this project, but obviously it's something that has to be done. So as I was explaining in the disassembly, each one of these splines is slightly offset, so it doesn't just fall right in. Well, that one it did, but usually you have to check it. So I just got lucky. You check it, you keep turning one spline at a time until you find one that falls in, because it's slightly offset. That way, no matter where this nut gets torqued to, the lock will always fit. Now, one of the things that I had mentioned was these retaining rings can get bent very easily. I actually was able to utilize one, but I did ruin one. So I buy these from McMaster-Carr. There is the part number. It is just a 5/8 internal snap ring. You can buy them by the, I don't know how many I bought here at once, maybe 10. They're cheap. Just get some extras if you're going to have one of these transmissions. Okay, so this is one of the used ones that I thought I could reuse. It doesn't seem to be springing into place very well. Another reason to have spares of these. Sometimes the groove is really hard to see, and so as you can see, I've got my handy little light so I can make sure that I'm getting the ring into the groove. Patience is key here. Okay, there we go. Now that cannot come out. No way that's coming out, and it should be fairly free like that. So won't be long to where this key will not be free like that. As the nut attempts to back off, it will tighten up, and that's the lock on that. So that's a really slick deal. So let's continue stacking this up. So that was a fairly quick from one step to the next. As you can see, I put in the shifter rod, which retains all of the shift forks. So now we're here at the back of the transmission. This is where we decide what drop gears we're going to run. So this is a 27-26 drop gear. In this case, we are wanting to overdrive it by 1 tooth, meaning this is going to be a 0.97 drop. So as it turns out, in these transmissions, 5th gear is a 1.03. With this drop of a 0.97, we have an effective 1-to-1 ratio from the input shaft to the output shaft. Now, they make a multitude of different drop gears, so you never really have to change your rear end. As I mentioned during the disassembly video, I like to run a tall rear end and then use my drop gears to get it what we need. You know, get the speed at the end of the straights that we need. The upper gear is just held with a circlip. The lower gear, which is our gear that drives, once again, it's a 27. The top is a 26, so we are overdriving this drop gear. Not by much, but by a little. So usually it just falls in. That one needed just a tick of persuasion. Not a big deal, but I was able to turn it and turn it and turn it and find the one that it was the closest at. And so now we'll just put our second clip in. And there we go. Emco provides these really nice nuts with an integrated flat washer that rotates. It's like an AN nut, which is like an aircraft spec nut. It's a really nice piece. And they have the oblong section at the top, which is like a self-grabbing nut. So in one of these transmissions, here's our basically our shift tower. So the center lever does all of the work. The outer banks hold the other gears in position when you're in another gear, side to side. So it's a fairly simple thing. So what I like to do is simulate that by just first getting all 3 shift forks in the middle and just slide through each gear, making sure that each one turns. Perfect. So then all we'll do is put the shift tower back on and we're good to go. We'll have this back into the car first of next week and shouldn't have any troubles. So as always, hit your like button, subscribe to the JPM Performance channel. Tell your friends if you like what you're seeing. I'll be doing a lot more of this moving forward. Hope you guys have a great rest of your day.